Hi guys, welcome back. I'm going to show you how to do a three variable system of equations. Now, this is obviously going to be another intersection, but these points will intersect in three-dimensional space, or planes, if they're planes, they'll intersect at a point there. They could technically intersect at a point in the real dimensional space. In case you're wondering what this looks like, if you're in a bedroom with a corner in it, if you look in the corner at the ceiling, you'll see that well, depending on if your roof's rectangular or not, but if you look at the top left corner or the corner of the room, you'll see three lines that intersect at one point. That would be an example of three planes because the roof is a plane, the walls that are adjacent to it are a plane. And so that one corner, that exact corner is where these three things meet. And so that's similar to kind of what's going on here, or a way that you can think about it. So notice that I've color coded these. I'm going to go through this example slowly. I'm going to explain everything I'm doing, and then hopefully you'll be able to repeat the process and do some student practice and get some, practice with this. So this is a little bit trickier. First thing we need to do is pick a variable to eliminate. So eliminate a variable. In this case, I'm going to choose y. And I'm going to explain why right now. If you look, 3 and 2 don't have a multiple that go into each other. 2 doesn't just multiply and give you 3, and vice versa. And similarly, 2 doesn't go into 5, and 3 doesn't go into 5. So x would not be a very good choice unless you want to do a lot of extra multiplication. In part 2, or in the red, you notice that y is -1, and then you have a 2y and a -3y. Well, if you multiply by 2, that'll cancel out a 2y. If you multiply by -3, that will cancel out the 3y on the bottom, the -3y. And so y seems like an okay choice. And then if you look again, 3 and 4 don't have multiples, so you'll end up multiplying twice. And 3 and 5 and 4 and 5 don't have multiples, so you'll end up multiplying twice. So you're just making more work by not choosing this one. Okay, as of right now anyway. That's just one way to kind of strategize for yourself. First thing I'm going to do, I'm going to use 1 and 2. So I'm going to use 3x plus 2y plus 4z is equal to 11, and 2 is 2x minus y plus 3z is equal to 4. Okay, so we've got these two things. Now I need to get rid of y, so I'm going to multiply the bottom equation by 2. And watch what happens. We have 1 is 3x plus 2y plus 4z is 11. And then our new equation 2 is going to equal, 2 times 2 is 4x. 2 times -2, or 2 times -1 is -2y. 2 times 3z is plus 6z is equal to 2 times 4, which is 8. We add this together. This is 7x. This is gone. This is plus 10z is equal to 19. Now, I'm going to label this one 4. Okay, the labels are important because they help you keep track of which equations you've used. Obviously, we've used 1 and 2. We have yet to use 3, so we have to use 3 in the next one, and we still have to eliminate y, because if we eliminate a different variable, you will have issues. I'm not going to do it in this video, but if you try it, you will have an x and a y, and maybe a y and a z, and you cannot eliminate in the next step after this. So let's go ahead and use another one. We're going to use 2, because I like that negative y. So I have 2x minus y plus 3z is equal to 4. That's the original. And we're looking at 3 now, and 3 was 5x minus 3y plus 5z is equal to -1. Okay, so I'm going to eliminate y again. I need to multiply this one by -3 because that will give me +3, which will cancel with a -3. So this is going to be 2. This is going to be -3 times 2 is -6x plus 3y minus 9z is equal to -12. Okay. Now we just add straight down. +5 and -6 is -x. -3 and -3 cancels, and 5 and 9, that's going to be -4z is equal to -13. Okay, and I'm going to label this one 5. Okay, so we've got the following. Let me make sure that that's good. Yes, this looks good. Okay, so now we have to use 4 and 5 in this case. Here's 4. Oops, sorry, that's 5. Here's 4. We have 7x plus 10z is equal to 19. And 5 is negative x minus 4. Z is equal to negative 13. Now, which one do you think I'm going to eliminate? If you guessed x, you would be correct. 4 does not go into 10 nicely. I would end up multiplying both by 2 different numbers, maybe 4 and 10. Although I think we could multiply the bottom by 5 and the top by 2, and that would also give me 20 and 20 and get rid of them. But since we're not doing it that way, we're going to multiply the bottom by 7, positive 7, because it needs to cancel with negative 7. This is going to be 7x plus 10z is equal to 19. And everything on the bottom is going to be multiplied by 7. So this is going to be negative 7x minus 28z is equal to 7 times 13 is, I don't know, 7 times 13, 91, negative 91. Okay, so we go from here. This is 0. This is negative 18z is equal to negative 91 plus 19, negative 72. Okay, so we divide by negative 18. And we get z is equal to 4. Okay, so we've got z is equal to 4 now. Well, we can back substitute, but we want to be very careful where we go to, because if we go too far, if we go to the original ones, we have an x and a y in those, and we don't know necessarily what x and y is. But fortunately, equations 4 and 5 are in terms of just x and z, so let's use one of those to get x from the other one. So we have negative x minus 4 times z, which is 4, is equal to negative 13. Notice I've used parentheses to make sure I'm not losing any signs. Negative x minus 16 is equal to negative 13. Add 16. Negative x is equal to 3. Divide by negative 1. X is equal to negative 3. Okay, so we've got that one now. All right. And then we go to our final one. We have 3x plus 2y plus 4z is equal to 11. We're going to plug those two values, negative 3 and 4. So we have 3 times negative 3 is 2y plus 4 times z, which is 4, is 11. This is negative 9 plus 2y plus 16 is equal to 11, which I believe is 2y plus 7 is equal to 11, which is 2y is equal to 4. Which is y is equal to 2. Okay, so now we've got our third one. So our solution here is negative 3 to 4, x, y, z. And that is where these lines intersect in three-dimensional space. Thank you guys for watching. Make sure you practice. Just do your best, guys. I know you guys can handle this. You got this. Thank you.